Hello and welcome back. First of all, I would like to thank you for supporting me in doing this good job. I want you to know that I always try to bring accurate and clear information to you. The sole purpose of me creating these videos is to help you understand those concepts that you always wanted to learn. At the end of this video, if you find it helpful, please do like, comment and share. If you are new to this channel, also hit the subscribe button in right bottom corner. With that being said, let's see what we have got today. Cisco AnyConnect. It's a remote access VPN technology. By remote access, what I mean is the user is sitting at home, he needs to work. This is office environment. So if you are sitting at office and you're working, you have got direct access to your company's network, right? If you need to work from home and you would like to access the same resources that you were able to when you were at office, how will you do that? You need a dedicated line, right? You need to just put a cable from your home to the office and connect it to the port where your PC or your laptop or maybe your desktop was connected to, and then you get direct access. Is it possible? No. Then how do you do it? So it's done via a remote access VPN technology. This user will use his internet connection and connect to this firewall remotely using a remote access VPN technology. He gets connected to the firewall, which establishes a VPN tunnel between this user and the firewall. Similarly, if there are other users who are sitting at home, they would like to have access to the internal network, he will do the same thing. Connect to the firewall using a remote access VPN technology, and that creates a dedicated VPN tunnel between that PC. Let's name it as PC2 and name this guy as PC1. That creates a tunnel between PC2 and the firewall. And same way, there can be multiple users and they can have all dedicated VPN tunnels with the firewall. So you know the purpose of VPN tunnel, right? The VPN tunnel, the VPN technology is to make you feel that you are actually connected to your official network. With Cisco AnyConnect, the connectivity will be like a user sitting at home using his own internet connection gets connected to the ASA or the firewall placed inside the organization. Once he gets connected to this firewall, he gets a dedicated VPN connectivity. A VPN tunnel gets created between user PC and the ASA, and all the traffic through this tunnel goes encrypted now. He gets to feel that he's actually sitting in the office and working because he's now able to access all the resources that are within the organization because he's connected to a firewall in the organization. The firewall has connectivity to all the resources. So Cisco AnyConnect VPN is a remote access VPN solution that provides connectivity to the users directly from their PC to the company's internal network using a software which is Cisco AnyConnect. In this session, we will see how to configure Cisco AnyConnect. For demonstration, we will use a Cisco ASA and one Windows computer. I'm going to divide the configuration into three parts: enabling feature, connection landing, and controlling the access. We first enable the feature on the ASA so that ASA starts accepting the VPN connections. In the connection landing, we tell the ASA, we train the ASA about how to accept that connection. And controlling the access. After connecting, what a user can access, that can be controlled. Cisco AnyConnect works on port 443. So it's TCP 443. That means when a user sitting at home tries to establish a VPN connection with an ASA in AnyConnect session, the connection gets established on TCP 443. Now, why would this ASA establish a connection with this PC on port 443? If this guy is listening on port 443, then he can establish a connection. Why would your ASA accept SSH? Because you enable it, right? You configure SSH and you enable it. Then only it accepts SSH connection. After enabling SSH connection, what you actually do is make your ASA listen on port TCP22. So if I go back to my ASA and check the ports that it's listening at, there will be one port 22 because my ASA is listening on port 22. That's why it's accepting SSH connection. So how do we check if the ASA is on what ports the ASA is listening on? So you can say show ASP table socket. If you see my ASA is listening on this IP address on port 22. So this must be the IP address on my outside interface where I've enabled SSH. So if I say show IP, it's gonna say yes, that's the IP on my outside. This ASA is listening on port 22. And because right now I've consoled in, so that's why you do not see any SSH connection established. So I can do another connection, do an SSH, and you will see. If I go here and check it again, ASP table socket. There's one that says listening on port 22, and another one is established connection on port 22. So this is my IP. From my IP, it has established a connection. Right, so we are not talking about SSH here. The only reason I've shown this to you because I wanted you to know what is the difference in listening and established. So if your ASA is listening on some port, then only you can establish a connection on that particular port. Same way, because AnyConnect works on TCP 443, so your ASA must be first listening on port 443. So to enable that, we have to do some configuration. So we will be going into Web VPN mode, and there we enable the Web VPN means AnyConnect. So it actually enables the ASA to listen on port 443. Right, so we enable it. On which interface do you want to enable? You tell the interface here, and then we enable AnyConnect, right? And a few more things. The ASA must have AnyConnect image in the flash. That image must be called here in the Web VPN configuration. So the first step would be go to Cisco website, download the AnyConnect package file. It's a .pkg for Windows, and upload it to your flash. And that's the file I'm talking about. So this is for particular version 4.3. You may get it for any version from Cisco website. You just need to have a valid support contract. Once you have the file in the flash, we can start doing the configuration for Web VPN. So you go to Web VPN and then say enable. If you do a question mark here, it's going to give you a list of interfaces that are available on the ASA. On which interface do you want to enable the feature? So I want to enable it on outside. The moment you enter this command, it's going to say Web VPN and DTLS are enabled on outside. The Web VPN means TCP 443 and DTLS is UDP 443. At this moment, if you check on what ports your ASA is listening at, so show ASP table socket. Now it's listening on port TCP 443 and UDP 443, which is SSL and DTLS. So that enables the ASA to listen on port 443. Good. Now we also have to enable the ASA to accept those connections from AnyConnect software. Right? To do that, we have to say AnyConnect enable. Now because you see the warning, it says no AnyConnect image command have been issued. So first we have to call the AnyConnect image from the flash to this configuration. Then only you can enable AnyConnect. So AnyConnect image, and where is the image stored? So it's in disk 0. The file name is of course AnyConnect, and I just hit enter here. So that is actually binding the image from my flash memory to the configuration. And now if I say AnyConnect enable, there's going to be no error. Right, so it has successfully accepted the command. If I say, now how do you check what configuration how do you check what configuration you have just done? So you say show run Web VPN. That's the config. Web VPN enable outside. So you're enabling the feature to ASA to listen on port 443, and then you're gonna enable AnyConnect. So to enable AnyConnect, you first must have the package file into the flash memory, then you can, so that you can call it in the configuration, and then you hit AnyConnect enable command. These are default configuration commands. Right, so we have gone through the first step to enable the feature on the ASA so that it listens on port 443. Once the feature is enabled, now we're going to go to step 2. Step 2 is, so for a connection to land on a particular tunnel group, you have to first configure the tunnel group. So tunnel group will be a place where your connection will first land. Now, it can also work without configuring any tunnel group, because by default the ASAs will have a default tunnel group, and if you just tweak some settings into the default tunnel group, you can get your AnyConnect working. But the problem with default tunnel group, using default tunnel group, is you don't have very granular control over it. Let's say you have various departments in your company, right? And you want to give them different access. Like if you have HR department, you want to give them different access after connecting with AnyConnect, right? Or you probably want to make them feel different, that once they connect to VPN, they choose something, let's say HR, and then connect to it, right? Then you have your IT, so you want to give them an option that if they connect to VPN, they choose an option IT and get related access. Similar way, if you have your tech support, and if they connect to VPN, they get an option to choose the tech support option and get that kind of access. So this kind of granular control is only possible when you create specific tunnel groups, right? Let's see how tunnel group can help us doing this task, achieving this task. You have to understand one more thing, like how does it work. So this is the remote user who is sitting at home. Here's your company's network, internal network. Let's suppose this user is at office, right? How does he work? He goes, he plugs into the cable to the LAN port and he gets an IP address. So probably he gets an IP address 10.10.10.1, and then he starts working. He can access all the internal network as well as intranet, right? Now if the same user is sitting at home, what IP address will he get when he connects to his intranet? So he will have a router by his service provider. Usually these routers are configured to provide you an IP address from this range, 192.168, probably 1.0/24. So you may get 192.168 1.25. Right? So this user will get this IP address. And similarly, all other users who are sitting at home connected to their ISP routers, they will also get IP address from kind of similar range, because these ISP routers, they've been configured with a pool to give you IP addresses from this range. This is a private IP address range, and so is this. This is usually used at home, in home networks. So everyone who is working from home might get IP addresses from this range. Now, this range of IP addresses is probably not, because this is private IP. Private IPs cannot go over the VPN. Cannot go over the internet. The sole purpose of using a remote access VPN is to get you a feel that you are in office. You have access to your internal network. And how can you get access to your internal network? If you get an IP address assigned from your internal network. So for a remote access VPN to work, this user must also get an IP address similar to what he was getting when he was in the office. We have to get the IP address as well. To get the IP address, we can use several methods, so we'll discuss them one by one when we keep moving forward into the series. Simplest way to do the IP address configuration on your ASA that will be to using an address pool. So we'll have to create an address pool on the ASA, so that from that pool it can give these clients an IP address. So once you're connected with AnyConnect, you will get one more IP address that will be from your internal network, and using that IP address you're gonna talk to your organization network, not with this IP. So there is a need to add create an address pool. So let's create an address pool. So how do we create an address pool? Command is IP local pool name, my pool, and then you can define a range of IP addresses. So let's see 10.10.10. Maybe 15 to 10.10.10. let's say up to 20, and then you can specify the net mask. So mask 255.255.255.0. So that's how you create a pool. So now pool has been created. We're gonna start configuring the tunnel group. So you're gonna say tunnel group and give it a name. So I'm gonna say ROS VPN, and its type is going to be, or let's make it more sensible. So I'm gonna create this tunnel group for my IT admins. So I'm gonna say IT admin, and the type. So this tunnel group is for which type of VPN? So it's for remote access. So we are creating this tunnel group for remote access VPN. Then in this tunnel group we are going to bind the address pool. So to bind the address pool, you'll have to go to tunnel group's general attributes. So the name is not correct. IT admin. You see general attributes. In the general attributes you can say address pool and the pool name. So what was the pool name? I think it was my pool. So I've created, we already had a pool created, my pool, so I've just called the pool name here. So we have got the address pool. Next thing we're gonna do is the third step. The third step was to control, configure something that can control your access. To control the access, we have to create a group policy. A group policy gives you too many options to control what a user can do after connecting. So the group policy gives you an option what a user can do after connecting with AnyConnect, what he can access. So I'm sure everyone needs that kind of control over what their users can do, and that can be done using group policy. So how do you create a group policy? Group policy name. So I usually prefer to give it the same name that I've just given to my tunnel group. That way I will know that this group policy is for this particular tunnel group. So group policy IT admin, and this group policy is of type internal. In this group policy, right now I'm not going to do too much configuration. I'm just gonna do a very basic configuration that's currently required, which is to enable the VPN tunnel protocol. What kind of protocol are we going to use? And that is done in group policy IT admin attributes. How do you do it? VPN tunnel protocol. What protocols are available here? So it's just two question mark. I say IP1, IP2, L3TP, IPSEC, SSL client, SSL clientless. For Cisco AnyConnect, we're gonna need SSL client. So just enabled VPN tunnel protocol SSL client. Right, so that's a very basic configuration we have done. Now we're gonna give it a shot. So 3 parts we have done our configuration. One is share and web VPN. We have enabled the web VPN feature on outside interface. We have enabled AnyConnect. Right. The next is we have created a tunnel group. So how do you check the tunnel group? Show run tunnel group. The tunnel group name is tunnel group IT admin. It's of a type remote access, and then you created an address pool and called it into the tunnel group. Address pool name is my pool. How do you check address pool? So you just say show run IP local pool. There can be more than one pools configured. You can call them in different tunnel groups. So I have 2 pools here. One is from 10.10.10.1 to 12, and then second one is from 15 to 20. So we have used this one. So anybody who connects to the VPN on a tunnel group IT admins, he will get an IP address from this pool. Now, where is the group policy? This was the tunnel group configuration. Where is the group policy? So the group policy is show run group policy, and we can give a name for our group policy, IT admin. That's what we configure in the group policy. Group policy IT admin internal, and in the attributes of the group policy, we have enabled VPN tunnel protocol as SSL client. Now, if you see, these things are show run web VPN, show run tunnel group, and show run group policy IT-admin. There is no relation between tunnel group and group policy except the name is same. So we have to find a way to bind them together. The way to bind them is you go to tunnel group IT-admin, tunnel group IT-admin, general attributes, and bind the group policy here. So how do you bind the group policy? You just say the default group policy for this tunnel group is going to be IT admin. And now if you look at the tunnel group configuration, you're gonna see show run tunnel group, that there is a group policy now. Default group policy is IT admin. So with that, we have completed the tunnel group configuration. It's time that we give it a shot. So I'm gonna open my Cisco AnyConnect. So I've typed in the IP address and hit connect. Getting a certificate warning because this PC does not trust the certificate presented by the ASA, because ASA does not have a certificate from a third party, and that's why my PC does not trust it. So about this, I'm going to do a different video to help you understand how this works, the certificate thing. For now, you can just say connect anyway. It's asking you for username and password. So of course, I didn't tell you that I've already configured a username and password on my ASA, local username and password. I'm not using any AD, Active Directory or LDAP for now. There may be an option later point of time in the series. So I'm gonna use Cisco. That's what I've configured here. It says login denied, unauthorized connection mechanism, contact your administrator. See the message. It doesn't say that my username and password is incorrect. It says login denied because you are using an unauthorized connection mechanism. That's strange. Now, how do we figure out what's wrong? So usually one thing comes into the mind, let's do debugs. But in this case, your debugs will not help. But it's worth a shot. Let's enable the debugs. Debug, how do you enable debugs for AnyConnect? So it's a debug by VPN AnyConnect 255. That's the maximum level of debugging you can do. I'm gonna go here and hit connect once again, connect anyway, and you see nothing in the debugs. What you can do is you can look at the logs. So for that, you must have logging enabled, and you must have enough buffer memory available for logging. Show on logging. So here you see I've enabled the logging. Buffer size is pretty much, and then the level of logging you need is debugging. So I'm logging everything in the buffer memory of a level debugging. Okay, so this connection attempt that we just did must be stored in the logs. So I'm just gonna say show log. My logging buffer is too much. So it is what it is. So it's gonna have to wait for it to finish. Somewhere in these logs you will see this kind of thing. So it says device completed SSL handshake with client outside. So SSL handshake is completed. Then it says AAA user authentication successful. Local database username is Cisco. So that is good news that my user authentication is getting successful. So it wasn't an authentication issue. AAA retrieved default group policy. The group policy name is default group policy for user Cisco. So it says whatever group policy you created, irrespective of that, you are getting assigned a group policy whose name is default group policy. See here, it says again that you're getting default group policy. Username is Cisco, and you're getting a tunnel group. The tunnel group is default web VPN group. Wait a second, did we not create a tunnel group? We did actually, but the connection is still not landing on that tunnel group. It's landing on default web VPN group because that's where a default connection will land. When you do not create a tunnel group and a group policy, your AnyConnect connection will by default land on a tunnel group named default web VPN group. and you will get a default group policy assigned. So by tweaking the settings of this group policy and internal group, you can get your connection working. But of course, you will not get that kind of granular control that we talked about, that for different departments you can create different tunnel groups and give them different kind of access. If everyone connects to one tunnel group and get one group policy assigned, then they all get same kind of access. Our connection is making to the ASA and it's trying to connect, but the problem is it's not getting to the correct tunnel group. We wanted it to connect to the tunnel group IT admins, but it's not landing on that group. How do we make sure that it just goes there? If you would have noticed, when I was trying to connect with AnyConnect, it wasn't giving me any option to select a group. Or no, it was showing me that you are going to connect to this tunnel group. See, it just directly asks for username and password. No other option. We have to first enable the option so that when you hit connect, it gives you an option to choose the tunnel group that you would like to connect. How do we do that? So that can be done. To do that, we have to make two changes. One in the tunnel group. So show one tunnel group. You go to config mode, go to tunnel group, IT admin, and this change will be done in tunnel groups web VPN attributes. So if I do a question mark here, you will see tunnel group has these attributes: general attribute, IPSEC attribute, PPP attribute, and web VPN attribute. So we'll have to go to web VPN attributes and enable group alias. Group alias, you can give it any name you want, but I will recommend that we use the same name that as the tunnel group. So sorry, we'll have to say enable as well, because it says show internal group and it says group alias IT admin enable. That's not it. Just go back, go to your web VPN configuration. So let's first see what has been currently configured. Show run web VPN, and now I go into web VPN and you see tunnel group list enable. That enable the option to list down the tunnel group names. Once you enable this feature, it will start displaying the names of the tunnel group. But which tunnel group? The tunnel groups that have a group alias configured. Only names for those tunnel groups will be displayed. Which names? The name that you give here in the group alias, that name will be displayed. So let's see it. So if I say connect anyway, and there you go. So now you get an additional option to select a group, and by default there is one, because there is only one tunnel group where you have a group alias enabled. So now you are getting an option to choose a group, and you know that your connection is going to land on IT admin. So username Cisco and my password is going to be Cisco. So it's progressing. AnyConnect download or have updated blah blah blah, activating VPN adapter. So if you're there, that means your VPN is going to connect. It is connected. So just got a pop-up here, connected, status connected. You can go here, this gear icon, the mechanical gear, and you see status connected. The channel mode is tunnel all traffic. We'll talk about that later since I've read it out. So tunnel all traffic means send all the traffic over the VPN. Duration, how long this has been connected for, so 42 seconds counting. What is the client IP address? So this guy has got an IP address assigned 10.10.10.15. What is the server's IP address? So the server IP address here will be the IP address of the ASA on which interface it has connected. Bytes sent and received, how much data are we sending here and receiving, and blah blah blah. Right, so these are the details. We're just going to test if we are able to access something that is within our internal network. Let me show you the topology again. So in this topology, you have this ASA. This is the ASA where we are doing the configuration, where we have configured AnyConnect, and this is the PC that I have. Its IP address is 192.169.0.2. So let's see on the ASA. It must be running an ARP. Let's say show ARP. So there is one PC connected on inside 192.169.0.1. Sorry, 0.2. 192.169.0.2. Show IP, that's connected behind inside. So that's the inside network. Let's see if we are able to ping that IP. That will confirm the PC is live. Yes, we are. In this command prompt, if you do ipconfig, you will see the very first adapter will be your Cisco AnyConnect adapter. It says Ethernet adapter Ethernet 2, and that's where you are getting an IP address assigned 10.10.10.15. Subnet mask 255.255.255.0, and the default gateway is 10.10.10.1. So it usually takes the first IP address of that subnet as your default gateway. I've connected using Wi-Fi, so I'm gonna look for my real IP on the Wi-Fi interface. So that's my real IP here. Wireless LAN interface 192.168.1.100. That's the real IP. So you see this PC has now got two IPs, one for my actual Wi-Fi adapter, and the second one is for AnyConnect adapter. So when AnyConnect connects, it creates its own adapter, and that's where an IP address gets assigned, because you know the IPs are assigned on the adapters. To understand the flow, let's look at this diagram. This is the end user machine where you have AnyConnect connected, and you've got an IP 10.10.10.15, right? This user is then connected to this ASA. This ASA outside interface, this is inside interface, and this is where you've got a PC whose IP address is 192.169.0.2. This is 0.1. So now we have done a ping from here to this IP 192.169.0.2. So first thing, this traffic with the ping that you're doing, it must reach here on this ASA, right? In this path, starting from this PC, by reaching this ASA here, everything will be encrypted. So this will be your encrypted data here. So if you capture that packet here anywhere till the outside interface, you will not see anything. You will only see the encrypted data. What kind of encryption it is? It is HTTPS, SSL. Right, that's the encryption. SSL encryption it is. So if you capture the data on outside interface, you will not be able to see anything because that will be encrypted data. Once that reaches the ASA's outside interface and goes in, then ASA will decrypt it. Decrypt the data. After decrypting, it figures out the actual packet. So the actual packet will be source IP 10.10.10.15, destination IP 192.169.0.2. Then it checks it's behind my inside and should send it here, and then there should be a reply back. That should be the flow. What about this flow? What will be the IP addresses here? So this is the virtual IP that got assigned to him, right? This PC had some real IP as well, so I'm going to use some different color. The real IP of this PC was 192.168.1.100. That's the real IP on the physical interface. The real IP of this ASA is 192.168.1.104. That's the real IP of the ASA. Now let me tell you, this is very interesting, right? And if you understand this, you can probably figure out any problem with Cisco AnyConnect. Now how it works, this is the virtual adapter, right? It creates a packet. So the real packet from this interface will have a source IP of, I'm just gonna use the same different color here. So this will be the first, real packet whose source IP is 10.10.10.15 and destination IP is 192.169.0.2. So that will be the packet from AnyConnect adapter. Then it goes to the physical adapter of the machine. On the physical adapter, on AnyConnect adapter, this packet gets encrypted. When it leaves the AnyConnect adapter, it gets encrypted. After encryption, the packet becomes this. So this is your encrypted data. What is the data? This was the real data. Now this is encrypted. Once this data is encrypted, it gets another outer IP header now changes. And this theta, this packet will have an outer IP header. Source IP is 192.168.1.100, the IP address of your physical adapter, and the destination IP will be 192.168.1.104, the IP address of the server where the VPN is connected. So this was the actual data that was received on AnyConnect adapter, the virtual adapter who had this IP address assigned. That's why it is saying my source is this and destination is 192.169.0.2. When it leaves the AnyConnect adapter and goes towards the physical adapter, it gets encrypted, and this is the encrypted data, and an outer IP header gets attached. So the outer IP header now becomes the source IP is of physical adapter, and the destination IP is the ASA where the VPN has been established. Now this packet goes to your ISP router, which performs probably a NAT or a PAT, right? And then your source IP address again changes. So your source IP address becomes some NAT IP, destination IP remains same. In my case, because I'm doing this locally, usually you will have this IP address as a public IP, right? Destination IP, then it goes, because now destination IP is your ASA's IP, it goes to the ISP, and the ISP figures out where is this public IP, takes it there, that reaches this ASA. When it reaches the ASA checks that this is a VPN packet, it's an AnyConnect packet, it decrypts it. So it removes the outer IP headers, this thing, it takes it off. What you get? You get this actual data. So that is your decrypted data. That's how you get the that's how this data gets decrypted on the ASA. So now you know the concept of how this packet moves through different gears. So first thing we need to understand that this packet is actually getting decrypted here, and it should then go to inside, right, after getting decrypted. If we are able to ping 192.169.0.2, and that seemed to work. Let's do a debug on the ASA for ICMP, debug ICMP trace, debug ICMP trace 1, and if I do a ping again, I should be able to see those debugs here going through the ASA. So it says echo request from outside, from the IP address 10.10.10.15 to inside 192.169.0.2, and then there is echo reply from inside going to outside. So that's how it's supposed to be working. That's all for now. I hope this has been informative to you, and I would like to thank you for watching it. It is your support, your likes, comments that keep me motivated for bringing up more stuff like this. Please let me know if this has helped you. If you are new to this channel, also hit the subscribe button in right bottom corner.